Hi students, welcome to Max Point of View. Today we are going to solve each and every question that is asked in the previous year papers from the chapter spectrum. So we are going chapter wise so that you will understand it properly. Every question from the previous year paper based on only one chapter that gives you proper knowledge. So before watching this video, my suggestion is watch the complete videos of concept theory solutions if you have some numericals from the chapter spectrum. Then only you will understand what is the main intention of this previous year papers. We will get to know how the questions are different from the textbook questions. Whatever the knowledge we have, do you think that is enough to get the complete answer from this particular chapter? That is our intention. So it is not to try to get the answers, it is to try to understand how the questions are different from the textbook, so that first understand the complete videos, okay, concept theory solution numericals of this spectrum chapter, then come back to this, then only will understand properly. If you haven't seen those videos, all the links are available in the description box chapter wise. This is chapter number 6. So in chapter number 6 spectrum, the complete playlist is there. Watch that and then you will understand it better. And we know why we are not solving before 2017 questions and beyond 2025, because before 2017 the questions are very simple and direct. Most of the questions are direct questions and less number of questions are logical, but now it is not the trend. Okay, the questions are very much logical and very less direct questions are as in the board exam, and the syllabus was completely different before 2017. And now why we not solving beyond 2025? Very simple, because this is the current year 2025. Okay, now from 26 onwards we'll upload the complete solution for the papers as it is, then you will understand it better. Now we'll start our session with 2017 questions. Which of the following statements is true? Molecules of the smoke are bigger than the wavelength of light. Molecules of the smoke are smaller than the wavelength of light. See, that's why I told you before solving these kind of questions we should have the knowledge, okay, of that's a particular chapter spectrum. Then only we can understand and answer it accordingly. See here, very simple. What is the color of smoke? That is white color. Why it appears to be white? This we have learnt in concept video. Correct, concept and theory solutions. Here they are changing the question. So molecules are bigger than the wavelength of light and molecules are smaller than the wavelength of light. The color of smoke is white because the molecules of the smoke are bigger than the wavelength of light. This is what we have understood in the concept video or theory solution. Correct. So what is the answer for this question? Molecules of the smoke are bigger than the size of the wavelength of light. That's it. Next, 2018. See, now when it comes to spectrum chapter, the number of questions are very simple every year. So one maximum of 5 marks, you can expect till 5 marks. So in 2017 it was asked only for 1 mark. Now we'll go for 2018. Okay, define scattering. The smoke from a fire looks white. See, this question is related to previous year but not the same question. So define scattering. Scattering is a process of absorption and re-emission of light energy by the dust particles and air molecules in the atmosphere. This is the definition. So whenever a light enters, assume this is the dust particle or air molecule. Okay, whenever light enters, okay, this particle absorbs and re-emits the light energy. Okay, where these dust particles and air molecules are present in the atmosphere. This is nothing but the definition of scattering. Now we'll move on to second sub question. The smoke from a fire looks white. Very simple question if you have seen the concept video, and it is related to the previous year questions also. Listen, the smoke of fire looks white. Why? Because the molecules, okay, the molecules of smoke, the molecules of smoke are bigger than the wavelength of light. This is what you have to write first. Whenever something, okay, looks white, okay, huge, okay, dense white, that is because the molecules are bigger than the wavelength of light. Whenever light enters it, light from the fire, okay, enters it, okay, we know the size of the molecule. This molecule is bigger than the wavelength of light. Then all the colors, we know light entering from the fire as all the colors, correct? The colors from the light will scatter to a same extent. All the colors will scatter to a same extent. When all the colors are scattered to a same extent, it appears to be white. That is the reason. The same reason is for why the clouds are white in color. That's it. Now we'll move on to 2019. An electromagnetic radiation is used in photography in fog. Identify the radiation. We have one sub question. See, from the spectrum chapter we got easily when it comes to radiation, electromagnetic radiation. On which radiations we can expect the questions? Very simple. It should be either IR rays, infrared rays, or UV rays, ultraviolet rays. So only based on these two radiations we can expect the question, or whenever it is related to increasing order of the wavelength or decreasing order of the wavelength, we can expect the questions on all the radiations. But whenever the question is asked particularly, it should be based on IR, infrared radiation, or UV radiation. So this question has to be either IR or UV. We know we use, see, if you have seen the concept video where it is clear that, so it is IR radiation. So photography in fog, this is one of the useful property, okay, of infrared radiations. So what is the answer for first question A? Identify the radiation. Infrared radiation. That's it. This should be your answer. If you write just infrared, then also you will get full marks. Then why is this radiation mentioned by you is ideal for this purpose, used for photography in fog? Very simple. This infrared radiation have maximum wavelength. This is what you are going to write. It has maximum wavelength and it will not scatter much, okay, and it has least scattering, so that it can pass through fog easily. Only these two reasons are enough. It has maximum wavelength and the scattering is less for infrared radiations. That's it. Now we'll move on to 2020. Give reasons for the following. During the day, clouds appears white. Very simple. The same reason behind why the smoke appears to be white. See, when the cloud is made up of dust particles and water molecules, correct? Dust particles and water molecules. The size of the dust particles and water molecules are bigger than the wavelength of light entering through it. So what happens when the size of the molecules are bigger than the wavelength of light? All the colors which is entering that particular molecule will scatter to a same extent. All the colors from the light, okay, will scatter to a same extent, so it appears to be white. Simple reason. Okay, then we'll go for sub question B. Sky appears to be blue. This is during the day again. See, when it is appears to be blue, that means the distance between the earth and the sun is not the longest. Understand this one. Longest means the distance means maximum, then it appears to be red. When it is not least and it is not long, that means average distance, okay, then it appears to be blue. This is the condition. Okay, why? Because when the distance between the earth and the sun is long, not the longest, long, okay, these blue colors will scatter more because they have least wavelength compared to red. That is why it appears to be blue. That's it. If the sky appears to be red, why? When it is possible, when the distance between the earth and sun is maximum. So you have to talk about two things here. Okay, actually three things. One, the distance, then the wavelength, and scattering. The distance is medium. That is not the longest. It is long. Then blue colors have minimum wavelength, so it scatters more. That's it. Now we'll move on to 2023. Infrared radiations are used in warfare. Explain with a reason why. Very simple. See, infrared radiation, first, why they are used in war? During the war, they use it as signals. Okay, the signals, if I am sending, the enemy people should not see it, right? So these infrared radiations are invisible. Okay, invisible. This is one simple reason. Then the main reason is it has longest wavelength, and it will get least scattered. So wavelength is more, scattering is least. So these are the reasons why we are using infrared radiations in the warfare. Now we'll move on to 2024. Below, in an incomplete table showing the arrangement of electromagnetic spectrum in the increasing order of their wavelength. Complete the table. Gamma rays, X-rays, UV rays, visible rays, infrared rays, A, and radio waves. What is that A? What is the missing here? That is microwave. Okay, so what is the answer for A? A is microwave. Okay, microwave. Then we'll go for B. Name the radiations used to detect the fracture in bones. That is very simple. X-rays. Then name one property common between both A and radio waves. See, common property, it may be any radiation. Out of these radiation, the common property between any radiation, answer will be same. So we have, in the concept video, we have learned the common properties for all the electromagnetic radiations. Okay, we have 5 properties. From 5 you write any one, you will get the answer. So answer for this question we will leave it blank. Why? Because we have 5 different properties. You can choose any one properties from the 5. That 5 we have learnt in the concept videos. Okay, so here you should not always think about both A, that is microwave, and the radio waves. No, you should not think like that, because in the chapter we have only 2 radiations, infrared and UV radiations. Here they are asking about microwave, that is both in A and radio waves. These properties are not there in the syllabus. Okay, first you need to understand the syllabus. Only we are going to talk about, okay, when it comes to electromagnetic spectrum, we are going to talk about infrared and UV radiations. Here they are talking about microwave and radio wave. So we have to talk about the common properties of all the electromagnetic radiations. That is what we have learnt in the concept video. Now we'll move on to 2025. Name the radiations. First one, for which a quartz prism is used to study the spectrum. See, when it comes to quartz prism, it is definitely related to UV radiations. So answer for the first question is UV radiation. So this is the importance of learning the concept and coming to the previous year papers. Then you will understand everything. If you just come here without having that knowledge, then this will be very difficult. You will not understand it anyway. Okay, second, which are used in remote sensing devices. So whenever the questions are asked in these ways, okay, they are going to talk about UV rays and infrared and visible light only. Okay, which are the radiations used in remote sensing devices? That is, whenever it comes to remotes, it is IR radiations or infrared radiations. Infrared radiations. Then third one, which of these used in, okay, which are radiations used in traffic signals in India? That is visible light. We have used red, yellow, green, right? The same thing, visible light. In the bracket you can write red, yellow and green, because visible light has all the 3. But mainly you can write red, yellow, green where in traffic signals, and all these things are A. Then B, name one common property common to all electromagnetic radiation. In the previous question only I told you there are 5 different common properties. related to all the electromagnetic radiations. You can write any one. So if they ask you to write a common property between X-rays and microwave, or this one radio wave and infrared wave, whatever the electromagnetic spectrum they are talking about, radiation they are talking about, the common property we have only 5. Out of 5 you can write any one, you will get the full marks. Now we have completed all the previous year questions based on this chapter spectrum from 2017 to 2025. From 2026 onwards, we are going to give the solution for the complete paper. Okay, we can upload it because this is the present year. I will first the problem will be, first I will not get the question paper of 2026 in 2025. Second, we have some limitation in YouTube. We cannot add some content to the present video. Okay, if there is a video from 2017 to 2025, we cannot add the solution of spectrum from 2026 to this current video. So that is the limitation. That's why we are going to solve the question paper as it is. I think you have understood. Again, I'm telling you, before coming to the previous year solutions, you need to have the knowledge of concept, theory, solution as well as the numericals. Then only these videos will be helpful for you. Thank you.